Okay, last thing, let's practice solving equations using our graphing calculator. So first thing I'm going to do is I'm going to type this in, I'm going to type this and this into our grapher as two separate equations. Okay, so I wrote one equation as y equals one side of the equation, and then the other equation I graphed was y equals the other side. Okay, so we see that there are a lot of answers, and there's actually an infinite amount of answers. So let's start off with this one here. Now, if we look, every period, that answer repeats. So if we could figure out what this point is and what the period is, we could write an expression representing all those points. So let's use the tracing tool on our calculator to find that point. So I'm going to go menu, actually not trace, analyze graph, intersection. And I can go lower bound, upper bound, and it'll tell me that point there. Alright, now the reason why I did upper bound, lower bound's to the left, upper bound's to the right of the point we want to find. Okay, so that point is going to repeat every period, every full period. So let's find the period. So the period is going to be 2 pi. Let's find an easier number to read. Easier color, sorry. The period is going to be 2 pi divided by b. So divided by 3 over 2. That's the same thing as 2 pi times 2/3. So you get 4 pi over 3 is our period. So our answer, one of our answers, is going to be x is equal to 0.486, alright, plus 4 pi over 3 times n, where n is an integer. Okay, so integers are numbers like 1, 2, 3, or even like -3, -2, -1. Okay, so why I'm using integers is because I would have to add a full period to this x interval to find my next solution. So that's why you always want to add a full period. All right, and let's test this out. Let's plug in 1 here and see what we get, and then we'll see if that's a point on our graph. Okay, so I opened up a new calculator. So if you don't want to do that, you hit Control plus page, and then you can open up a calculator page without losing your graphing page. Alright, so I did that here, and I typed in 0.486, which was our point, and then I added 1 period, and I got that. So I went to see where this blue graph intersected the red graph next, and I got 4.68, which was this just rounded up. Alright, if I were to do this again, if I were to add like 2 periods, alright, I'd get 8.86, which means if I did intersection, analyze graph intersection, and I found that point, it would be 8.86. Alright, so now let's find the other point that repeats. Okay, so our next point that keeps repeating every period, but on like kind of like a different interval as the first point we found, would be this one right here. Alright, 1.61. Okay, so now if I wanted to express all these solutions, my second answer would be x equals 1.61 plus the period times n, where n is an integer, which means as long as I plug in a whole number, positive or negative, in for n right here, then this whole expression will give me one of my x coordinates that is a solution to our original equation. So let's try a negative now. Let's plug in -1 and let's see what happens. Okay, so I did my other point, 1.61 plus 4 pi over 3, but now plus -1. And I get the point -2.578. So that means that if I take this point here and then subtract the full period, that should take me to this point right here. So that should be at the x-coordinate -2.57, or rounded up to 2.58. Okay, and it should have the same y-coordinate, 4. So let's test it out. Let's go analyze graph intersection right here, and there it is, -2.58, which is exactly what we would have predicted from subtracting a full period from this point, 1.61. And see, that's where we got right there. All right, so that's any equation you can solve with a graphing calculator by graphing both sides and seeing where they intersect. It's just with trig functions, they're going to intersect an infinite amount of times, so you want to write an expression to express all those solutions.